Welcome to On Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episodes. This is the episode number 3. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 part P questions step by step. Stay tuned. Let us see the question number 1. One is cyclooctane with 3 double bond and one in conjugation with cation. Second thing is cyclopentadiene, which also in conjugation with cation, and you got 3 member cation with 1 double bond. So A, B, C, 3 compound. They are asking their aromaticity, whether A is homoaromatic or heteroaromatic or anti-aromatic. So the 3 types of aromaticity is possible here. You have to identify which and which. So from the question you might guess the condition for the aromaticity. The answer is A. Let us see how. The compound A is homoaromatic. Let us see how. The starting metal you have only one carbon which is not in the conjugation. So here the aromaticity can be artificially established by lifting out the carbon from the plane. So carbon is lifted out of plane and create the artificial aromaticity. The artificial aromaticity is called homoaromatic. It has 4n plus 2 pi electrons. So no problem, aromatic but homoaromatic. Second thing is all things are in conjugation, no problem, but it has 4n pi electron. So it is the anti-aromatic system. Third thing, obviously 4n 2 plus electron because it has 2 pi electrons. So it's aromatic system. So the A is homoaromatic, B is anti-aromatic, C is aromatic. Here I given the concept which is condition for aromaticity. For aromaticity it has to be 4n plus 2. It is planar. If it is not planar but you can create 4n plus 2 conjugation, it is called homoaromatic. Anti-aromatic means 4n electron. Non-aromatic means non-conjugation or no planarity is called non-aromatic. Non-aromatic means the no aromatic possibility is there. Then the question number 2. Here they given the 3 compounds. One is ketone, another is amide, another is anhydride. Here they ask you to find the stretching frequency of carbonyl. Which one is higher? Here anhydride can be higher, or amide can be higher, or ketone can be higher. Here they are asking the trends of the vibrating frequency or stretching frequency. From the question you might understand the question is about functional group versus stretching frequency. The answer is D. Let us see how. Here we have 3 choices. One is carbonyl, which is only attached with carbon. The stretching frequency should be middle. The question is really about whether the anhydride is higher or the amide is higher. The anhydride is higher because it is attached with the electronegative group. What really electronegative group do is it pulls the electron towards it, so the carbon-oxygen bond gets shorter. The shorter bond you can consider as a triple bond or higher order bond. That's why stretching frequency is higher. What happened to amine? Amine can donate the electron. It can be in the conjugation or in the resonance. So the double bond getting single bond character. So stretching frequency obviously it will be decreased because the double bond is weakened to single bond there. So the order should be anhydride is higher, ketone is neutral, amide is lesser. Here what concept you should learn? Conjugation decreases the stretching frequency because it reduces the double bond character. Second thing is electronegativity increases stretching frequency because it decreases the bond length. Then the question number 3. Here you have cyclohexane which has one tertiary butyl group and methyl group. Both are in transposition. The bonds are not specified there. Here the question of butyl and methyl position is asked there. The answers are both can be axial or equatorial or axial, or both can be equatorial or both can be axial. So from the question you have to guess which group decides the structure. The answer is B. Let us see how. The starting metal is trans, so there can be the two trans possibility, which is tertiary butyl group in axial position, methyl in equatorial. The another possibility is tertiary butyl in equatorial, methyl in axial. So which is stable? Here you should know the point which is called locking group. The bulky group is called locking group because it frees the structure. It arrests the structure. Because the axial tertiary butyl in the bulky form have the hydrogen steric effect. Because hydrogen has steric effect with this methyl group. Here I shown it as insert. Steric effect, you can visually see the hydrogens are very steric and the carbon is also very steric. So it should be an equatorial, not an axial. If it is an equatorial, the methyl should be an axial. So the answer will be tertiary butyl and equatorial, methyl and axial. Here you have to learn the concept locking group. Locking group is called arresting group because it decides the structure, it frees on the particular point. Normally the bulky group is the locking group. Here the tertiary butyl one, which always occupy the equatorial position. Then the question number 4. The starting metal you have azo compound which is attached with 3 fused system, which is pentane ring attached with 2 benzene ring. You are using the light, they ask you to find the intermediate. Next step you are using the alkyl. You have new 3-member ring is formed. Here the choices are given which is intermediate means the free radical or carbocation or the carbene ion or the carbene. Here you have to understand that the question is really about reactant instability and which intermediate is formed there. The answer is D. Let us see how. Here the starting metal you have azo compound, you are using the light. The nitrogen is a very weaker bond, is suddenly removed from the system, you have carbene as the intermediate. So the answer is D there. Next step you are using the alkene. The alkene turn into singular form and combine with alkene, it form 3-member ring which is desired product. Here the concept is carbene formation. Why the carbene formation formed from the azo? Because the nitrogen is the triple bonded compound N triple bond N, which is very stable triple bond formation. It is an easy leaving group. Small trigger can eliminate it. Sudden loss of 2 bonds in the single carbon creates a carbene there. So it's a very much important. CN2 bond is very weak. Even the little trigger gives the carbene there. Here you are shining the light, you get the carbene here very clean way. Then the question number 5. The starting metal you have the conjugated ketone, you have one side methyl, another side dimethyl. The product they given without the double bond, they ask you to find the product. Only the conjugated double bond is managed there or reduced there. Here 4 choices are given, 4 are reducing agent. The first reducing agent is lithium aluminum hydride, second is hydrogen, third is boron, the last one is lithium in liquid ammonia. The question is about selective reduction of alkene. So you have to understand that the chemoselective reduction is occurred. Which reagent involved here? The answer is D. Let us see how. The starting metal you have conjugated ketone, only double bond is reduced. Here the possible and meaningful choice lithium in liquid ammonia because it supplies the electron, reduce the double bond, and the ammonia can donate the H+. You have the reduced alkene there. The other reagents are selectively reduce the carbonyl or it also reduce the carbonyl. Here chemoselective achieved by lithium in liquid ammonia. Here you have to learn the concept. Here chemoselective reduction only by lithium in liquid ammonia. It involves only the reduction of double bond there. Other reagents reduce the carbonyl, not the alkene. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.